You guys can see my program?
Yes.
Okay.
Yes, Doctor.
So you can see what I'm typing right now.
Yes.
Debug.
Debug.
Okay, and then I type R. So we display my register. Okay. So what registers are available? So for today, we're going to learn to look on the flag. Okay. For example, in this one, I have the flag listed on the left side over here. So what I have is this one, NV, okay, NV, UP, okay, EI, PL, NZ, okay, NA, PO, and NC. Okay, so that's my flag. Okay, so for the flag, what I have here, NV is for overflow, all right? So V is for overflow. If you have overflow, then the code will be OV, right? But if you don't have any overflow, then the code will be NV, right? And then you have UP, it's up. So whether the direction is going up or going down. So whether you have up or down, down is DN, and then I have over there is EI. So over there, my interrupt is enabled, right? If DI, then my interrupt is disabled. Okay, so that's for the interrupt flag. And then we have here PL. So PL is plus or positive. And conversely, we have NG, which is negative. Okay, that's related to the sign flag. Okay, so if you have your number 1 bit at the bit 15, right, as you learned before, at bit 15 you have 1, then your flag show NG, okay, instead of PL. Other than that, if it is 0, then your flag will still be 0. Okay, meaning that your flag will show it PL. Okay, and then what else that we have? Okay, we have 0 flag. Okay, over here it is non-zero. Okay, it is non-zero. And then okay, it is non-zero. If we have 0 flag, then the flag of ZR, okay, ZR will display. Okay, and next we have NA. NA is for A is for auxiliary. Okay, so auxiliary, remember that. So when you have this 4 bit and then another 4 bit, so if at the middle there between bit 3 and bit 4, sorry, between bit 4 to bit 5, there is carry 1, then you will have the auxiliary carry flag as 1. So when your auxiliary carry flag as 1, you will have there as AC, right, instead of NA. Okay, and then you will also parity flag. Okay, the parity flag. Okay, so parity flag is calculating the number of ones. Okay, the number of ones at your result. If the number of ones in your result is even, okay, then you will have the even parity, which is, so that is PE. Okay, over there you have PO. So when you have PO, the parity is odd. So meaning that the number of ones in your results is Alright, meaning that it can be either 1, 3, 5, 7, 9, and so on. Alright, and the last we have NC. Okay, so we have NC. It is a carry flag. Okay, so after the bit, the 8th bit, okay, after the 8th bit, if you have carry flag, okay, then after that, what you will have is 1, then you have carry flag as CY, okay, and over there is given NC because you don't have any carry, so non-carry, so no carry, so the code. Okay, so let's do some okay, let's change that. If you want to change that flag, we can do that. Okay, so this is how to do that. First of all, okay, so I just want to list out my flag. So I type R again and F, okay, F for flag, and then I press enter. So you show that, okay, flag. Okay, so for example, I want to make my overflow. There's no overflow, then I want to make my overflow, so I put OV, okay, and then let's say I want to change my my zero flag, okay, non-zero, okay, I put Z, so I put ZR, okay, in any order. It doesn't mean for you to follow the order of the flag if you want to change that, okay, so it can be in any order. So over here, so I have OV and I have ZR, and then one more, I want to make it down, okay, the direction is down, okay, then I press enter. Okay, so you want to show back your flag, so you can show that, type R and then F, you see that, so you see that it changed. So now your NV becomes OV and UP become DN, and last one NZ becomes ZR. All other flags, all other flag registers are still similar. Okay, so if you now you still have the chance, you want to change it again, but here I just press enter. Okay, so now the flag is not changed anymore. Okay, so you can go back and then you just type R and you see, okay, that's your flag right now. Okay, because it doesn't matter if you change the flag, because the flag will be affected after you do the operation. Okay, the operation is related to move, add. Okay. All right, we're going to do some operation now. So we're going to do some operation. Okay, let's say I have, okay, as usual, I have A. I want to start, if you want to start with the operation, you need to go to the assemble mode, all right? So assemble mode where you can type move, add, instruction, okay? So I start with 100. So why you need to start with 100? Okay, because normally below 100, the registers are reserved for the operating system. For your program, you need to start from 100 and above. Okay, so in order to avoid you have conflict later with your operating system before you already manipulate the register inside that. Okay, so I have A100. Okay, and then I press enter. Okay, so the first one, what I want to do, I want to put move, then I put CX 5. Sorry, I want to move AL, for example, AL as 9C. All right, as 9C. Then I want to move DH 64. Okay, now I want to add both of that, L and DH. So let's say I add DH to AL. So I add DH to AL, right? And then I just stop that program. So I put interrupt 3. Okay, I just press enter again. Okay, now the program is terminated. Okay, so I want to look back what happened before. All right, what happened between between add, move, and move. All right. So as I mentioned before, if I want to check what has been done before, so we put the command T. T is for trace. Okay, so T, let's say 3 steps before. So it is from 106. Okay, at interrupt 3. Okay, 1 step. Okay, another 1 step and another 1. Okay, so it will be up to move DH64. All right. So 3 steps before. So I put T3. Okay, so you can see that your flag now change. Okay, your flag now change. Okay, after you put the add, okay, so you remember that. So what number you have? 9C and 64. Okay, did you remember on how you perform the addition and calculation of that before? Okay, do you still remember that? Okay, so let's go back to the calculation. Okay, we can double check that. Okay, because now what you can see from the flag itself is you have no overflow. Okay, and then the direction is down because the direction is not changed. All right. So because you states down, then it's still down, and then EI, your EI is the interrupt. So interrupt is still enabled. Okay, you don't change the enable interrupt. So what change is only on auxiliary. So you have the auxiliary to reflect AC. Okay. Before that, you have an A, non-auxiliary, right? And then you PE, all right? PE is for the parity, okay, even parity. So you have, before you have odd parity, okay? So now meaning that you have your one as even. The total number of ones is even compared to before, all right? So before that initial state, and then we have lastly CY, we have the carry flag. Okay, so let's have a look what has happened actually. Okay, so let's have a look to the results. Okay, by the way, give me one. Okay, let's do the calculation manually. Okay. All right. So C and 64. Okay. So this equals to what? We have 60. Okay. So this is equals to what? So what's your... Okay, so you need to change that to binary first, as you remember. Okay, so for C, what do you have? So your C is actually 13. All right, your C is actually 13. So what is that number in the binary? Anyone can help me? Anyone have an answer? So what is C in binary?
1100.
1. 1. 0, 1, right? That's 10, 12. Sorry, it's 12. C is 1100. Okay, and 9. So 9 is 1, 0, 0, 1. Okay, so you guys get that? Right, and about 64. So we have, for 4, we have 0, 1, 0, 0. And then for 6, we have 0, 1, 1, 0. Okay, so like that one. So now we want to perform the addition. Okay, so what would be the result? So the result here, okay, if in terms of base 16, okay, I just put, if it is base 16, so I add C with 4, it is 16, right? So 16 minus 16 is 0. So it's 0, and then here it's also 16, so it's 0, and then you have 1 there, right? So this is your carry, 1. Okay, but for this one, so you add 0, 0, and 0, 0, and 1 plus 1 is 1, 0, right? So we have 1, 0. So 0, we have 1 added here. Okay, so you have 1 added there. And then from bit 4 to, so meaning that your auxiliary carry flag will be 1. So that's why you have your AC, right? AC is, so your flag is AC now. Okay, so you have 1 here, and then 1 plus 1 will be 1, 0. So you have, still we have 1 plus 1 will be 1, 0. Okay, you have 1, 0, and then you have 1, 0, still 1, 0. And then you have, of course, you have 1, 0. Okay, so basically that's the result. Okay. So you have what is changed here. So you have 0 flag, right? Because all of that are 0. And then you have carry, and you have the auxiliary carry flag as 1. So this is what is shown over here. Okay, so this is what is shown there. All right. Okay, so you have your what is changed. So you have still have 0 flag. Okay, and then you have the AC now. Okay, so you can verify you have AC, and then you have, okay, one more is parity. So now you have 0 ones, right? So that's why you have the parity as even. Okay, so you have the even parity, and then you have the carry flag. Okay, so that's it, right? So when you perform the addition, okay, so that's how the flag change. Okay, we have one more example. So let's have a look at this one. So just want to clear that. So I put Q, all right, and then I put debug again, and then type R. So that's my register. So that's my flag register, and then I have P100. Okay, so let's say I put move PX 34 F5. Okay, and I put add PX 95 EB. Okay, so I want to add, okay, 95 EB to 34. Okay, so I stop there. So I interrupt 3 and then enter again. Okay, then T. So back to previous number. Okay, so that is what is listed. Okay, so okay, you can see that now you have NG, right? Before that you have the PL. So what is NG? So NG is a negative, all right? So meaning that your sign flag now has changed. So you have negative, and then you have the what else? AC, you have still have auxiliary carry flag, okay? And then what else do you have? You have PO and C, so that remains unchanged. Okay, so your number there, is 34 F5 and 95 EB. Okay, so let's have a look. So this will be 16-bit, right? So before that, so you need to perform the addition up to the 16-bit. With 34 F5 and 95 EB. So you have 34 F5. So you have 34 F5. So that will be equals to 345 erase 0 1 0 1, and then so you first it will be 1 1 1, and then you have 4 it is
0100.
0 1 0 0. Okay, what else we have? 3.
3.
You have 0 0 1. Okay, you have 0 0 0 0 1 1. Okay, next your number is 95 EB. So your B is 11. So what is 11? B1
0111.
0 1. And then you have E, so it will be 1110. Okay, so that's your E. And then you have 5. So 5 is 0101. And 9 is 1001.
Doctor,
Yes,
the B is 110. 1011.
1 which one?
101 for the B.
1010. Yes, 1010. Thank you. So it's 12, right? Sorry, it's 9 AB. B is 11. So it should be 001011, right?
Yes,
Yes.
doctor.
Okay. Okay. All right. So how do you perform the addition of that? So basically, you just look first at the low 8-bit, okay, at the low 8-bit, okay? Because after that, there's something here. So we change the sign, all right? Okay, so let's have a look. Okay, so we add 1 1, so it should be 0, and 1 1 will be 0 1, so it's still 0 1, okay, and then it's also 0 and 1. So you have the AC there, auxiliary carry flag. 1 1 1 0. Okay, so you have now you have 1, because you have 1 1, and then you also have 1 1. Okay, and then you also have 1 1. So now you have the carry over. So you carry over there. You need to carry that. So you carry that to the 8-bit. So that will be 1 1. So it will be 1 0, right? So and 1. Okay. So we don't have any. You don't need to carry anyone after that. So now it becomes 1 1 0 1. Okay. And then for 1 1 it will be 0 1. So 0 1. And then you have 1. So that's best. Okay, so what you can observe there. So you have the AC here, as you remember. So you add 1. So your AC. So let's verify. Okay, so you have negative. So you have, because you have the carry over there, right? So you have carry bring to the from the 8. Okay, from the sorry, you have AC. Okay, and then you have the okay. So, okay, the negative and positive is actually depends on the bit of number 15. All right, bit number 15. So because you have the bit number 15 is 1, right? So over here you have 1, so it is negative. Okay, so it is negative. All right, so and then you have AC as 1, and it is non-zero. And then you calculate your, over there you try to calculate your parity. So your parity is odd over there because it's 3, right? So you calculate for the only for the 8. Okay, so you have 3 ones. Okay, you have 3 ones over here. So you have 3 ones. So it is odd. So because it's 3, so it's odd. So you have that as PO, okay, odd parity. Okay, so that's how you did the addition of the 16-bit number. Okay, 16-bit number on the flag. Okay, so that's how it changed the flag. All right. Okay, for the last one on the debug program, before we move to the chapter 2, I'm going to show you some simple program. Okay, some simple program that you can do on the debug. Okay, so let's say, I have, I quit and then I type debug. Okay, I type debug. Okay, and then A100. Okay, so I want to move CX 05, so CX 05, and then I want to move 0200 to BX, and then I want to move L, And then I want to add the address of BX, the offset of BX, okay, to AL. And then I want to do the increment of BX. And I want to decrement of CX. So increment will increase 1, okay, 1 bit by 1 bit. Okay, and decrement also will decrease 1 bit by 1 bit. Okay, let's say I have a jump instruction, which is the jump not 0. If the result is not 0, then it will jump to back to 0108. So what's its meaning here? So it will go back to the offset address of 0108. So what do we have there? At 0108, you have add offset of address of BX to, so it will be a loop. Okay, as long as the result, okay, the result is not 0. Okay, the result is not 0, the process will be repeated. Okay, the process will be repeated until the result is 0. Okay, all right. Once the result is 0, then it will continue with the next instruction. Let's say I have move 2 0 5. Okay, I want to content of AL to the address of 0205. Okay, and then I want to stop that, drop 3, then enter again. Okay, now let's say, okay, I want to use the E command. So E is for, as you remember that we learned last week, okay, where E is we want to alter the data. Okay, so we want to alter the data. And then we have also the command D, so we want to delete. So we want to delete the data. Sorry, D is dump. Okay, so we want to dump the data. Sorry, it's not delete. So it is dump. So dump means we need to display that. So that's why we dump the data. Okay. So first of all, I am interested in showing the data. Okay, so I have E 0200, so at the address of 0200. Okay, and then I want to alter the first one. Okay, 25 12 15 1 FN to B, for example. Then I want to dump that. Okay, 0200, and then dump that to the location up to 020F. Okay, 020F. Okay, so that's the result. Okay, as you can see that, so we have E is entered there at the first one, the register location number 1, 25 12 15 1 FN to B. Okay, and then the rest is the original content of the offset address of 0200. Okay, and then I want to put G command, so which is the go command. Go to the location of 100 to 111, so until the interrupt tree. Okay, so I enter that. All right, so this is what you have. So your AX already changed to 96, and your BX is 0205, because what you did there, so you increase, okay, you increase BX up to 5, and then you decrease CX up to 0. So when CX is, you will not jump, okay, so you will not jump to 108. So you follow the instruction of moving AL to the content of 0205. Okay, and then okay, once you go there, and then you want to see again, you want to dump that value. All right, so you want to dump the value. So what you can see there is the content of AX. Okay, so the content of AX will change. So over here, we want to dump 0200, okay, 020F. Okay, so as you can see, okay, I press enter. Okay, you can see the changes. Okay, so now the 20, okay, now the 20 becomes 96. Okay, so the 20 becomes 96. Okay, because you change the content of AX over there. Right? So that's how you program to add 5 bytes. Okay, to add 5 bytes to that number. Okay. All right. So that's how you did that. Okay, so basically you go back, okay, you go back and then you check. So basically your BX is initially 0200, and then you move the content of BX, okay, move the content of BX into AL, right? So basically you have AL as 02, AL is that at that location of BX of 0200. So what is that? I don't know. So okay, if you want to check, so you can do the, if you refer back, if you want to check the content of that, you need to refer that back to, you put the address of G, okay, 100 to 200, okay. So let's say, okay, let's say I go to G equals to, let's say I put 200, okay, 200 and into 200. So that's the, actually the content of that. Okay, it is given over there, right? As you can see. So over here, we have, what do we have right now? So at 0, 1, so that's the command. And then, so the information over there is given, as you can see above. So you have D, okay, so you have D0200, and then 020F. So meaning that you want to display all of the content of 0200 up to, okay, up to 020, okay, 020. And then, so after that, you go to that command, right? And then you change the value of over here, which is 20. So you change that to the 96. Okay, so that, okay, and then I have another one. The program is A100. So I quit first, and then I do debug, and then I type A100. I want to move SI 0210 to move PI 0228 and move 6 to CX. I want to move the con SI. So the I into AL. Okay, and then I want to move the content of DI. Sorry, DI. I want to move the content of AL into DI. And then I want to increment SI. So increase 1 by 1, increment DI. And then decrement CX. Okay, jump not 0 to address 0109. So you go back to 0109 if the result is not CX. Okay, so CX is actually 6 steps. Okay, 6 steps after that, it will be 0. Okay, once it will be 0, then you can do interrupt. Okay, and then enter. Okay, first of all, let's look at the steps. So let's say I have how many steps there? So let's say I want to trace let's say up to 5 steps. That's what you have. Okay, so basically, what you have over there is the value you looked at when you increment. So it will follow the steps of increment SI, okay? And before that, I cannot see what is on the above that. And then, never mind, I will just show you the last one. So which is R. So 06, so AX is 0066, okay, and then you have CX. So CX is already 6 steps, okay, because you already Okay, you already moved that CX. Okay, so you already moved that 6 to CX, so your CX is still 6 even though you, okay, so even though you do the decrement, and then your, okay, so your SI is 0210, okay, and then your DI is 0228, okay. So basically the content of the SI at the address of 0210, you put that into AL. Okay, so that's why you see AX is having 00 at the AH, and it has 66. It has 66 at the AL. Okay, so right, so that's how your AX change. Okay, now if you want to go, you want to enter the location of 0210, okay, and 25 for F, and 85 and 1 F, 2B and C4, okay, and you want that 0210, 022 F, okay, and then so that's what you have. You go to the 100, you go to 100, and then you see that now the content of AX change, right? The content of AX, this is the initial content of AX, okay? Initial content of AX where you have at the G starting of address of 100, okay, and then let's go to D021. Okay, you want to dump that at 0 to F. Okay, so you see the difference there. So what changed? The result. So you see that the lowest 4 bit of that change. All right. So the content of now becomes 25. Okay. Number of 66 becomes 25. All right. So basically that's the content from X. Okay. All right. Any questions so far? So to perform this calculation, you need to revise back the last week one. So where we have the G command, the E command, and also we have the D command. So we have G, which is go to the address, and then E, we want to manipulate the data. So we change at part of the data, right? And then D, once we want to, you must put the command of D so we can change that. So we need to dump that information. Okay, so basically that is how the, once we perform the calculation, all right, and then we want to insert that value. Okay, let's say over here, we put the value of AX into that address. Okay, so that's how it is changed. Okay, so let's have a break for 10 minutes, okay, before we continue. So if you have any question, okay, if you have any questions so far, you can ask me. Okay, for the flag, which code corresponds to which flag? Okay, so you need to type R. So it will display your register and then space F. Okay, so you put R and F, so that will change. Okay, if you want to change the flag, okay, if you want to manipulate that, so once you type this, it will display you the flags, alright, and then there is a dash there. So after that dash, you change that, okay, to which value that you want to change. Okay, let me open that again. Okay, enter debug. Okay, and then type R. Okay, so you have R. So you have your flag over there. So you type RF. Okay, so over here you can change your flag. Okay, so NV, right? NV is for overflow, all right? So overflow is not related here, okay? So overflow will only change, let me check that, because uh, over here when we perform the move and add instruction, it won't move any of that, right? NV and UP, okay? So it will stay there, okay? Because when you perform that, there will be overflow when you perform. How can I change that? Let me give you an example. Let me have a look for example first. Give me a few minutes. Okay, I cannot think of a good example right now for the overflow flag. because it's actually involved with a signed and unsigned number. So the overflow flag will be affected if there is a signed number, right? So right now I cannot give you a good example of that. I need to look further. So I'll get back to you later, right, on that. And for the direction, it won't actually change because you perform the only move and add instruction. Okay. Let me have a look if I have a good example on that. Okay, let me perform the I need to think of a number, all right? So the direction will change when you have the bit 10 change, right? When you have the bit 10 change, then you will have the direction flag change. Okay, for example over here, so at the number, let's say we just, I refer back to the number of 3, 4, and 5, 9. So if you have 1 at the bit 10, then it will change the direction. If it's down, then it will go up, and then if up, it will go down. Okay. So you might think of a number, right? Because we need to think of the number that actually can change the flag. By the way, yeah, it will take some time to think of a number because first of all, you need to think that number in terms of binary, okay, and then convert back to the hex, okay, and then to see whether it changes, then you need to convert back to the binary, okay, and then perform the addition, and then change a little bit from there, okay, and see you use a different number, and then change back to hex, and from hex change back to the binary, and then perform the addition to see whether you got the different number. Okay, once you got the different number, and then you can put in into your debug program, and then do the programming and to see whether there is changes in the direction flag, whether it changed from DN to UP or from UP to DN. Okay, so all right. So I'm going to open up the slides on the chapter 2. We will continue that for 20 minutes. All right. So by the way, I'm going to send you that on the WhatsApp. So basically now we are on the assembly language programming. Okay. Okay, Haziq cannot attend because the storm killed his Wi-Fi. Okay, I just share you the slides on the second chapter. Alright, so basically you have chapter 0, chapter 1. So the first one is actually about the history of computer, alright? And then you have chapter 0, which is about the logic gates and so on, the basics for microprocessor. And then chapter 1 is what we discussed, okay? Is about the flags, storage registers, what is inside the CPU itself. Okay, and then we're going to continue that with the assembly language programming. Okay, so by tonight, you're going to get a set of assignments that you can do yourself. And then, because right now I'm still, I have the questions, but I need to put up the answers as well, so you can do that. Okay, so you can check whether you did that correct or not. And actually, the assignment also, you need to submit that. Okay, the due date will be after the test. After the test. Okay, after the test mean that after your semester break. Okay, after your semester break. Okay, okay, let's continue with the chapter 2. Okay, so all right, so in this chapter, so this is what you will learn. All right, so you need to be able to explain the difference between assembly language instruction and pseudo instruction. So you should be able also to identify segments of assembly language program and code simple assembly language instruction. Okay, assemble, link, and run a simple assembly language program. Code control transfer instructions such as conditional and unconditional jumps, as you see just now. So you have J and Z instruction, jump not zero, jump JZ, so jump 0, okay, and call instruction. And then put the assembly language data directives for binary, hexadecimal, or ASCII data, and write an assembly language program using either the simplified segment definition or the whole segment definition. So you will also learn about what is the segment definition, okay, and explore the usage of MASM and MU8086 assembler. Okay, so you will use a different assembler later. So right now you use debug, okay, to do the assembly language programming. Okay, so what is the assembly language? So assembly language is a series of statements or lines. Okay, so either assembly language instructions or statements called directives. Okay, so what is directives? So directives is we give the direction to the assembler about how it should translate the assembly language instructions into the machine code. Okay, so you remember that when you type U, okay, you will see the machine code at the besides the physical address. Okay, so that's the machine code. Okay, the assembly language instruction consists of 4 fields. First, the label, okay, and then mnemonic, and then operands, and then comments if you want to put comments. Okay, and then the bracket indicates that the field is optional. Okay, the field is optional. So mean that the label, the operands, and comments are all optional. Okay. Okay, so the label field allows the program to refer to a line of code by name. Okay, so the label field cannot exceed 31 characters. And then a label must end with a colon when it refers to an opcode generating instruction. Okay, and then we have the mnemonic and operands field together accomplish the task for which the program was written. Okay, for example, over here we have the mnemonic. Okay, mnemonic opcodes are the add and move, for example, and then EL, BL, and then EX 6764 or what are the number or what are the registers that you put on are the operands. Okay, so that's the mnemonic and the operands. So you need to be able to distinguish that, right? So instead of the mnemonic, and this field could contain assembler pseudo instructions or directive. Okay, so the directive, they do not generate machine code and are used only by the assembler as opposed to instruction. Okay, so directives will be direct. Okay, compared to instruction, we instruct the machine what to do. Okay, for example, we have the directives RDB, okay, and NP. Okay, instruction, by the way, is move, add, okay, INC, DEC, increment, decrement. So that is instruction. So the directives are example of that. We have DB, okay, the database, okay, DB, and then NP, N program, and N. Okay, so that's the directive. Okay, the command field begins with a semicolon and then maybe at the end of a line or on a line by themselves. Okay, so you can put comment on the code. Right? So the assembler ignores command. Okay, commands are optional but highly recommended to make it easier to read and understand the program. Okay, so this is what we have. Okay, so you can see that after the first two commands is the model directive. Okay, so you can see that command, the first command is the form of an assembly language program. Okay, so that's one command, and then the second command, note using simplified segment definition. And then we have the directive. So that is first is the model directive. Okay, so this directive selects the size of memory model. Okay, so we just select. Okay, we don't instruct, we just need to select because the model of the memory is already available. So we choose dot model small. So we choose the small memory size. Okay, and then these are the other options that you can have. So you can have either small, medium, compact, or large. Okay. So the directive defines, okay, model small. This directive defines the model as small. Okay, medium, the data must fit into 64 KB, but the code can exceed 4 KB of memory. Model compact, okay. So compact can exceed 64 KB, and then, but the code cannot. So it is reversed, okay. It cannot exceed 64 KB. So model we have for large, okay, both data and code can exceed 64 KB, but no single set of data should exceed 64 KB. Okay, and then we have huge, both more code and data can exceed 64 okay, data items, okay, such as arrays can exceed 64 So that's the difference. Okay, so for large, no single set of data should exceed 64 and then the data item can exceed 64 Okay, and then the last one we have tiny, okay, which use with the COM files in which the data and code fit into 64 KB. So you can see that the difference between the memory model, okay, with the, either you have small, medium, compact, large, huge, or tiny. Okay, so every line of an assembly language program must correspond to an x86 CPU segment register. Okay, so basically we have the what segment? So we have the code segment, we have the data segment, and then we have the stack segment and the extra segment. Okay, so it must correspond to the segment register as we just what we did in the previous chapter. Okay, so the simplified segment definition format use three simple directives. Okay, so to choose this segment, so which one that you want to choose is by using the directive. For the directives is either dot code, okay, dot data or dot stack. Okay, so for dot stack, of course, we use the SS register. Okay, for the data, okay, for the data, so we use dot data. So we use the DS register, and then dot code, we use the CS register. Okay. So the stack segment defines storage for the stack, and then the data segment defines the data the program will use, and the code segment contains assembly language instruction. So it is distinguishable, okay, for the different different segment, okay, register, okay. So it has also different function, okay, whether you want to use the stack, okay, the data or the code segment. Okay, so for example here we have dot stack. So the dot stack 64. So the directive reserve 64 bytes of memory for the stack. Okay, so we move on. So we have the data as well. Okay, so this is data segment, right? So we have first we define the directive of memory that we want to choose dot model. Okay, and then dot stack. Okay, we choose the size of stack that we want to use, and then we have the data segment that we want to use. Okay, we have over here we have three data items, which are data 1, okay, data 2, and sum. Okay, so the DB directive is used by the assembler to allocate memory in the byte size chunk. Okay, so each is defined as DB, defined bytes. Okay, and then memory can be allocated in different size. Okay, and then the data items defined in the data segment will be accessed in the code segment by their label. Okay, so the DB, is the defined byte. Okay, so defined byte directive, okay, is used by assembler to allocate memory in byte size chunk. Okay, so actually the memory over there is actually is allocated, okay, in terms of byte 1 byte, 2 byte, 3 bytes, and so on. Okay, data 1 and data 2 are given initial values in the data section. Okay, sum is not given any initial value, okay, but storage is set aside for it. So for example, we want to do the summation, and then only the sum, only the sum on the data segment will have some value after we do perform some calculation. So that's the difference between data 1, data 2, and sum. So that's why we have at the DB, we have the ask symbol, okay, the question symbol. Okay, so the first line of the segment after dot code directive is the prop directive. So it's still directive. Okay, so this is the program entry point. So prop is a procedure. Okay, it's a group of instructions designed to accomplish a specific function. So a code segment is organized into several small procedures to make program more structured. Every procedure must have a name defined by the prop directive. Okay, so you must have a name, okay, for every procedure. Okay, and then it is followed by the assembly language instruction, okay, enclosed by the NP directive. Okay, so we look back. For example, here, okay, so we look back. So we have the instruction after the procedure. Okay, so we have move 1, 2, 3, 4. For move, after that we perform the add, and then move, and then interrupt. So from move up to interrupt is all the instruction. Okay, it's not the directive. Okay, so until interrupt, it is instruction, and then NP and N is are the directives. Okay. Okay, so the prop and NP statements must have the same level. So before that, we have prop and var, right? So NP must also be used with var. So NP var. So the prop directive might have the option far or near. Okay, whether it's far or near. Okay, so the OS requires the entry point to the user program to be a far procedure. Okay, so for a user program, we should use a far procedure, not a near procedure. So the user program is the one that we execute by ourselves. So before the OS passes control to the program, so it may execute, it assigns segments values. Okay, so when the program begins executing, only CS and SS have the proper values. Okay, and then DS and ES values are initialized by the program. So by default, CS and SS only have the proper values. Okay, so we have moved AX, okay, we move data. So data refers to the start of the data segment. Okay, so we move AX to DS. Okay, for example, this one. So the program loads AL and BL with data 1 and data 2. Okay, so the data is actually called at the first instruction, which is okay, alias data, okay, is moved to the AX. Okay, so when we move data to AL, okay, and then we perform the addition of BL to AL, so we have the data 1 is added to data 2, okay, and then we have AL, okay, and move to the memory location of sum. Okay, moves to the memory location of sum. So for the last instruction, so we have moved for CH to AH and we put interrupt 21H. Okay, so the remote control, so we have it is return control to the operating system. Okay, once we perform the interrupt control. So when we perform the interrupt instruction, okay, and then NP, okay, NP, so we end the main program. So as you can see that. So you must put main. So main, and NP. So we can close that loop and then end main. So we end all of the program. Okay. So please keep it handy to keep a small sample. Okay, and fill it with the instruction and data for your program. Okay, so I'll stop there for today. All right, we have a brief overview on the assembly language, okay, where this is not be performed on the debug, okay, but it will be performed on another assembler, either MASM or on the MU8086. Okay, any questions so far?
Not yet.
Any question, Ambo? No question?
Not there.
Okay, so let's turn on the camera to take our picture together for the attendance today. So where are you, Syada?
Dekat college, Doktor.
Oh, you're now in the college?
Ya.
Oh, why you buy at the college?
Apa dia doktor?
Kenapa dekat college?
Sebab MPK banyak tugas.
Oh, alright.
Okay.
Because only final year batch only at the college right now, right? Should be.
Yeah, that's right.
Okay. Alright, so everyone is ready. So let's count from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, give me one more shot. Okay, Amira, stay there. Okay, thank you everyone. Okay, selamat berbuka for those who's fasting. Alright, so there will be no class on Thursday because it's a holiday, Nuzul Quran holiday. And then by tonight, I will give you the assignments. Okay, so you have time until until the Hari Raya break. Then you can submit the assignment. But I will give, don't worry, I will give you the answer straight away, so you can check with that. But if you have any question, if you don't get the answer, if you do the practice, you don't get the answer, then let me know so I can help you. Okay. By the way, we'll see again on next Tuesday, right? So the last class before we have our test one on the next Thursday. Okay. All right. So that's it for today. Have a nice day. Okay. Assalamualaikum and bye bye.
Thank you, doktor.
Thank you, doctor.
Thank you, doktor.
Thank you, doctor.